Hello students, in the previous lectures we have defined continuity and discontinuity of three types and discussed algebra of continuous functions. So discontinuity are of three types. One is if left limit exists and right limit exists, both the limits are equal but not equal to the value of the function. That is zero discontinuity. If left limit exists and right limit both exist, both are not equal, then we said this is a discontinuity of first kind. If left limit exists, right limit does not exist, or left limit does not exist, right limit exists, then this discontinuity is called discontinuity of second kind. Now in this lecture we will discuss problems based on the continuity and discontinuity of function. First question is the function fx is equal to n minus 1 for x equal to 1 and is then natural number, and this and fx is equal to 1 minus x by n upon 1 minus x if x is not equal to 1, continuous at x. If discontinuous, then state the kind of discontinuity. So now the function fx is equal to f is equal to 1 minus x is by n upon 1 minus x for x not equal to 1. So we are not supposed to find both the limits because the function is the left of 1, it is the function is same, and right of 1. So we find the limit x goes to 1 of fx, and the function at as x goes to 1, whether from the left or right, the function is same, is equal to 1 minus x to n equal to 1 minus x, limit x is 1. So this is the value function here. Now using the formula a is to n minus x to n is equal to a minus x into a to n minus 1. So 0 is to n minus 2 x plus e to n minus 3 x square, and so on is 0 x to n minus 1 in case of a 1 into x to n minus 1. After substitution, this formula x minus 1 cancel out from this from numerator denominator, and the limit for this will be, now when we cancel out the counter, we got a polynomial function for limit x equals to 1. So if it is a polynomial function, we will substitute the x will be replaced by 1 itself. So 1 into 1 into 1 plus 1 plus 1 plus 1. So in this, there how many terms are there? There are x equal to 1 equal to x minus 1. There are n terms. N terms, so 1 plus 1 plus n times is equal to 1. So limit x is to x equal to 1 from left and right both is equal to comes out to 1, but the value function at 1 is going to be n minus 1. So if we replace the value function at 1 by 1, we can make this function fx to be continuous. So after removing the value of 1, f1 is n, replace the value of f1 by n minus 1 by replace n minus 1 value of f at 1 by n. So we can make this function continuous at 1. So this from first and second, we can conclude that this function is discontinuous at 1, and the discontinuity kind of discontinuity is removable discontinuity. Now next question is examine the continuity of function fx is equal to under root of 1 plus x minus under root of 1 minus x upon x for x not equal to 0, and 1 upon 5 for x equal to 0 at x equal to 1. We will examine the quantity at x equal to 0. Now again when x is not equal to 0, x equal to 0, this is equal to 1 by 5. When x is not equal to 0, from left and right the function is same. Again, we don't find the left and right limit at 0, we just find the limit at both limits will be same. That's why therefore limit x is 0 of x is equal to, substitute the value for the function, limit x is 0 of 1 root of 1 plus x minus 1 into x. Now in order to find the limit, this limit, this is it. If we replace it to 0, this is 0 0 form. written form. So in order to evaluate this, we just rationalize it by numerator, taking the sign, and this will become a plus minus b to a b, a square minus b square, and root will be removed, and in the middle get when we get 1, this comes out to 2x, this comes out to be uh, 2x upon x cancel out, this will be 2 upon under root of 1 with x plus 1 become 1 minus x. Now, when we replace x by 0, in determined form is removed and we get 2 upon 1 plus 1 plus 0, this is rational function, and plus 1 upon root of 1. This comes out to be under the point 1, under the point 1, but the value function at f0 is equal to 1 by 5. Again, left limit x to 0 of fx is 1 and right limit is also 1. Both limits are equal, but the value function at 0 is equal to 1 5. If we replace the value of fx at 0 by 1, now we can make this function continuous. So again, first check implies the function is discontinuous and this discontinuity is a removable discontinuity. Examine the discontinuity of this function. Fx is equal to root of 1 minus cos of 2x over x for x1 to 0 and 0 for x to 0 at x to 0. We discuss this discontinuity at 0. Now again, in the left of 0, the function is same. Right of 0, the function is same. Left of 0, the function is same. Right of 0, the function is same. In case of discontinuity, spare the right discontinuity. If this function is discontinuous, so we'll decide which value is now fx is equal to 0 to be just 1 minus cos plus the root of 1x for x to 0. Then, so using formula cos plus equal to cos x plus sin square x. Cos plus 1 minus cos plus equal to sin square x by x by x or 2 by x. X is 0. So root 2 is common. Root of square of sin modulus x upon x by x not to 0. And now for continuity, limit x is 0 of fx is equal to x. That is, if x is to 0 to negative of fx, then 0 to positive of x is equal to x. Now, why we discussing left hand table? Because modulus function, modulus function, we have to find the code. Limit x is 0 from negative f x is equal to 0 of negative of 1 to x of tan. So now x is 0 from negative, 0 to negative, substitution x is equal to 0 minus x is 0 to negative, and x is equal to 0, x is equal to positive. And sine of minus theta equal to minus sin theta or also minus x equal to x. So after putting value function fx here and root 2 constant outside, limit x is 0 of modulus of sine of 0 minus x upon 0 minus x. Modulus of minus x minus x minus sin x to modulus of results because root 2 limit x is 0 of sine upon x. This comes out to 1 is the 2 minus x. Again, the right hand substitute the 0 x is 0 positive and f x to limit x is 0 positive of root 2 is small sign on x. Again, substitution here, put x equal to 0 plus x equal to 0 as x is positive is 0 from positive. So after substitution, we got constant outside limit x is 0 of also sign of 0 plus x upon 0 is equal to when this is sign of the x sin x or sin x equal to sin x finite, so this is the discontinuity function, and because the left limit and right limit both exist, both are not equal, therefore this is discontinuity of the bracket is discontinuous at zero and this discontinuity of first. Discuss the continuity at x is zero of the function fx is equal to sine inverse of modulus x, x not zero and zero if x is zero. So we know the modulus x is equal to x if x is equal to zero and minus x is equal to zero. So in the left table, left of zero, uh, zero value of modulus sin x is equal to minus x. So we have to find both x. Limit x is zero from negative of x equal to zero from negative of sine inverse of modulus x is equal to 0 from negative of sine inverse of minus x. Therefore this is equal to sine of minus x, sine inverse of minus x minus sine inverse of sine of sine inverse of minus of sine is equal to put x equal to sine inverse of minus x equal to b, sine of x equal to b, therefore x equal to sine of b, x is equal to negative, equal to so put b equal to b equal to 0 minus x equal to 0 to negative, 0 x equal to 2 minus limit x equal to 0 from negative of after substitution minus limit of 0 of the minus first. Similar right integral I substitute 0 from positive is equal to limit x 0 from positive of sine inverse of modulus x, modulus x of 0 from positive, modulus x equal to x, limit x 0 or from positive of sine. And then put this to t and make substitution from south to 0. Left limit is 0, right limit 0, so the function at 0 to 0, the function is constant, right? Possibility implies function is constant, right? Left limit is equal to 0, right limit is 0, and the value function at 0 is equal to 0. Function is constant, right? And next question is examine the quantity of sine of f is equal to x sine convex minus 1, then x is equal to 0, 0, then 0, f is equal to 0. Now, the function fx is in the left neighborhood of 0 and right is the same, and value f at 0 is 0 if the continuous give the nature of this function. Equation first is the given function. Let fx equal x and h is equal to 1 side. Therefore, fx equal to gx into x minus 1, then x equal to 0. And now limit x is 0 of gx equal to 0. hx is the boundary for Lx, therefore bounded in the neighborhood of x. Therefore, hx is a bounded in the neighborhood of 1, 0. Using the theorem, limit x is to a of gx is 0, hx is bounded in the neighborhood of a, therefore limit x is to a of gx is equal to 0. So, second and third, implies limit x is 0 of x is 0. Now, substitute it here. Limit x 0 of x is minus 1 is equal to sum is difference of limit of x 0 of x into sin of x minus limit 0 of 1. Because this is 0, 0 minus 1 is 1. But value at 0 equal to 0. So, fourth confusion implies left limit at 0 and right limit at 0 is equal to minus 1. But value of function 0 is equal to 0, 0 is discontinuity and fx is discontinuity 0 and 0 will discontinuity. If you put f0 is equal to minus 1, the function becomes continuous at x. Examine the continuity of this function. Now, fx is equal to 1 plus x, if x is less than equal to 2, and 5 minus 2, x. Now, fx is the polynomial function in the left neighborhood of x, and it's one function in the right neighborhood of x. So, value of the left root of x is equal to, you can greatest is the value, limit will be 3, and the right order of this value gets equal to 2, the left limit is equal to 3, right limit is equal to 3, right is equal to 2, so, and f at 2 is equal to 3. So this function is left limit is equal to 3, right limit is equal to 3 at x is equal to 2, and value function at f is equal to 3. So this function is continuous at x is equal to. Examine the quantity of function defined by f is equal to modulus of x minus a upon x minus a for x not equal to a, and 1 x equal to a at x equal to a. Again, this model function we find f that limit x is to a negative f x is equal to negative of modulus of x minus a upon x minus a. Put x is equal to a minus x equal to 0 as x is equal to negative x is equal to 0 from first. So this is here limit 0 a minus x minus a equal to minus x minus a cancel out. We are left with limit x 0 of modulus of minus h upon minus h. Modulus of minus h is equal to minus of limit x 0 is equal to. Similarly, right limit is equal to x is to a negative of f x equal to 1. So b plus here and 10 plus that we define the right. So left limit is minus 1, right limit is 1. Both limits are finite, both are not equal, therefore they display function discontinuous at x equal to 0, x equal to x equal to a, and this is discontinuous first term. Now next we prove that the function f is equal to x upon modulus x minus x for x not equal to 0 and a for x equal to 0 remains discontinuous at x is 0 regardless of value. This is a quotient of fx upon gx minus h function. So the domain is model function is included here. Domain instruction this function is included. This is a real number, this is a real number, this is a real number, and model is involved, so you find left and right. That's fine. Left limit is 0 from negative. Index 0 from negative of x is equal to 0 from negative of x upon model x minus 2x. Put x equal to substitution again 0 and such x equal to 0 as x equal to 0 from negative x equal to 0 for substitution here given the set given set x is 0 substitution here after simplification minus x upon modulus minus h 2h modulus minus x equal to h smooth this will minus the limit x to 0 of h upon h common cancel out equal to minus of limit x to 0 of h upon 3h that cancel out. Similarly, right limit 0 from positive of f x equal to x equal to positive of x upon modulus x minus 2x. Again substitution here x equal to put x equal to x plus 0 x plus 0 x x plus x equal to 0 plus h x equal to 0 as it is 0 from positive x is 0 from positive. You do substitution here this x 0 plus h numerator and limit will be changed from x 0 from positive to x 0. So after calculation we are left with limit x 0 of h upon modulus h minus 2x. Modulus h is equal to h. So after simplification, limit x 0 of h upon h minus 2x equal to 0 of h upon minus x. Left limit comes out to minus 1 by 3, right comes out to minus 1. So the function is discontinuous at x equal to x as x equal to 0 at x is 0 and this is discontinuous first one. Now left limit is 1 by 3, right limit is equal to 1. This is the discount first time. So whatever value of k will may be left limit and right limit because left and right limit are not equal, so the function can't be continuous at x equal to. Let f(x) equal to 1 if x is less than equal to 3, a plus b plus b is less 5, 7, x equal to 5. Determine the constant a and b so that f may be continuous for all. Doubtful point of this quantity is r equal to 5. So we find the limit at 3 and 5. So 5. So determine the constant f is continuous. So me there are 3 points me because you have to find the derivative. You have to make the this function continuous the whole of the domain. So we will discuss the quantity at 3 and 5. Means our aim is to show that limit x of fx is equal to f of 3 and limit to actually 5 of f x equal to f5. From these equation we will find the constant here. So limit x approaches to the constant. So this they are equal fx equal to this. So limit x is equal to negative of f x equal to limit x is equal from positive of from negative is equal to function is 1. So limit x is equal to 1 constant function limit is 1. Now limit x is equal to positive of x equal to limit x is equal to positive of x t is equal to 3 into 3 into a plus b. Now f3 is equal to f3 into f3 is equal to how much? Equal to 1. F3 is 1. So similarly, we got an equation 3a plus b equal to 1. 1 Now similarly, limit x is to 5 of fx equal to limit x is to 5 from negative of ax is 5 ax is function. So this a to b, so this poly function will be 5 a plus b. Now limit x is 5 to positive of x equal to limit x is 5 positive of 7 is to 7. So left equal right limit f5 is to 7. So left equal right limit equal to 11 because function continues at 5. So 5 equal to integration 5 equal to 7 from equation 6 and equation 10th we can find the value of a and b. This comes out to 3 and b comes out to -8. For a equal to 3 and b -8 the function becomes continuous in both of the domain. Next is for what value of a and b will the following function be continuous for all x? Now in the same question is this is the question fx equal to 3 13 if x is equal to 2 and ax equal to bx plus 1 if 2 is less than x is less than 3 and 17 minus 2x if for what we do. Now our aim is to find the derivative that the function fx continuous whole. The output point are 2 and 3. So we'll do the limit. Since fx is continuous for all x, so therefore fx is continuous at 2 and 3. Set of 2 points. Since f is continuous at 2, so limit left limit at 2 of x, right limit of 2 at x equal to f. And similarly, now let's find the left limit at x is equal to positive of f equal to this will 30 constant function. Limit is equal to negative. The limit of this will be 13. Okay, right limit at x equal to of f equal to limit x equal to positive. The following function will again substitute x plus fixing the limit and make substitution, or we can directly substitute x into 2. We get the same result. For the one function, we can substitute for the left limit, right limit is 2, or we can make substitution. Both is put x into 2 plus x, x equal to 0, add x equal to 2 plus x. Make substitution and simplification for 4a plus 2b plus 1. Now equation first, second implies, but f2 is equal to 13. So function first, second, third implies 4a plus 2b plus 1 13 or equal to 4a plus 12 and 2a plus 6. Since f is continuous at 3, therefore left limit 3 of fx is equal to right limit 3 of fx is equal to f of 3. So left limit of fx is 3 is equal to limit x is equal to negative of this. Again now the following function we can replace x by 3, or we can use both will be sorted. So the limit comes out to be is equal to 9a plus 3b plus 1 plus 1 1 is equal to 1, and the right limit is equal to, as it comes out to be second Poisson function is equal to 17 plus 3 minus 3a, and value at 3 is equal to value of 3 is equal to 1373. So now the equation left is equal to 1373, value is 1373. So 56 and 75, 17 of 52 is equal to 9 plus 3 plus 1. So after simplification, we got 12a plus 3 equals 16. From this equation 8 and equation equation 6, we can calculate the values of a and b, which comes out to be b equal to 20 by 3 and a will be minus by 3. The function will become continuous at x equal to for all x of x.